Welcome back. Now, let's talk about the important concept of running tensors or PyTorch objects. So running tensors and PyTorch objects on GPUs and making faster computations. So we've discussed that GPUs, let me just scroll down a little bit here. GPUs equal faster computation on numbers. Thanks to CUDA plus NVIDIA hardware plus PyTorch working behind the scenes to make everything hunky-dory. Good. That's what hunky-dory means, by the way, if you've never heard that before. So let's have a look at how we do this. Now, we first need to talk about, let's go here, getting a GPU. There's a few different ways. We've seen one before. Number one, easiest, is to use what we're using right now. Use Google Colab for a free GPU. But there's also Google Colab Pro, and I think there might even be, let's look up Google Colab Pro. Choose the best that's right for you. I use Google Colab Pro because I use it almost every day. So yeah, I pay for Colab Pro. You can use Colab for free, which might be what you're using. There's also Colab Pro Plus, which has a lot more advantages as well. But Colab Pro is giving me faster GPUs. So access to faster GPUs, which means you spend less time waiting while your code is running, more memory, longer runtime, so it'll last a bit longer if you leave it running idle. And then Colab Pro again is a step up from that. I personally haven't had a need yet to use Google Colab Pro Plus. You can complete this whole course on the free tier as well. But as you start to code more, as you start to run bigger models, as you start to want to compute more, you might want to look into something like Google Colab Pro, or let's go here, options to upgrade as well. And then another way is use your own GPU. Now, this takes a little bit of setup and requires the investment of purchasing a GPU. There's lots of options. So one of my favorite posts for getting a GPU is, the best GPUs for deep learning in 2020, or something like this. What do we got? Deep learning. Tim Detmers. This is, which GPUs to get for deep learning. Now, I believe at the time of this video, I think it's been updated since this date, so don't take my word for it, but this is a fantastic blog post for figuring out what GPUs. See this post for what option to get. And then number 3 is use cloud computing. So such as GCP, which is Google Cloud Platform, AWS, which is Amazon Web Services, or Azure. These services, which is Azure is by Microsoft, allow you to rent computers on the cloud and access them. So the first option, using Google Colab, which is what we're using, is by far the easiest and free. So there's big advantages there. However, the downside is that you have to use a website here, Google Colab. You can't run it locally. You don't get the benefit of using cloud computing. But my personal workflow is I run basically all of my small scale experiments and things like learning new stuff in Google Colab. And then if I want to upgrade things, run bigger experiments, I have my own dedicated deep learning PC, which I have built with a big powerful GPU. And then also I use cloud computing if necessary. So that's my workflow. Start with Google Colab, and then these two if I need to do some larger experiments. But because this is a beginner course, we can just stick with Google Colab for the time being, but I thought I'd make you aware of these other two options. And if you'd like to set up a GPU, so 4, 2, and 3, PyTorch plus GPU drivers, which is CUDA, takes a little bit of setting up. To do this, refer to PyTorch setup documentation. So if we go to pytorch.org, they have some great setup guides here. Get started. And we have start locally. This is if you want to run on your local machine, such as a Linux setup. This is what I have, Linux, CUDA 11.3. It's going to give you a conda install command to use conda. And then if you want to use cloud partners, which is Alibaba Cloud, Amazon Web Services, Google Cloud Platform, this is where you'll want to go. So I'll just link this in here. But for this course, we're going to be focusing on using Google Colab. So now let's see how we might get a GPU in Google Colab. And we've already covered this, but I'm going to recover it just so you know. We're going to change the runtime type. You can go in any notebook and do this. Runtime type, hardware accelerator, we can select GPU, click save. Now this is going to restart our runtime and connect us to a runtime, aka a Google Compute instance with a GPU. And so now if we run NVIDIA SMI, I have a Tesla P100 GPU. So let's look at this, Tesla P100. GPU, do we have an image? Yeah, so this is the GPU that I've got running. Not the Tesla car, the GPU. So this is quite a powerful GPU. That is because I have upgraded to Colab Pro. Now, if you're not using Colab Pro, you might get something like a Tesla K80, which is a slightly less powerful GPU than a Tesla P100, but still a GPU nonetheless, and will still work faster than just running PyTorch code on the pure CPU, which is the default in Google Colab and the default in PyTorch. And so now we can also check to see if we have GPU access with PyTorch. So let's go here. This is number 2 now. Check for GPU access with PyTorch. So this is a little command that's going to allow us or tell us if PyTorch, just having the GPU here. This is, by the way, another thing that Colab has a good setup with, is that all the connections between PyTorch and the NVIDIA GPU are set up for us. Whereas when you set it up on your own GPU or using cloud computing, there are a few steps you have to go through, which we're not going to cover in this course. I'd highly recommend you go through the getting started locally setup if you want to do that, to connect PyTorch to your own GPU. So let's check for the GPU access with PyTorch. This is another advantage of using Google Colab. Almost zero setup to get started. So import torch, and then we're going to go torch.cuda.is available. And remember, CUDA is NVIDIA's programming interface that allows us to use GPUs for numerical computing. There we go, beautiful. So big advantage of Google Colab is we get access to a free GPU. In my case, I'm paying for the faster GPU, but in your case, you're more than welcome to use the free version. All it means is it'll be slightly slower than a faster GPU here. And we now have access to GPUs with PyTorch. So there's one more thing known as device agnostic code. So set up device agnostic code. Now, this is an important concept in PyTorch because wherever you run PyTorch, you might not always have access to a GPU. But if there was access to a GPU, you'd like it to use it if it's available. So one of the ways that this is done in PyTorch is to set the device variable. Now, really, you could set this to any variable you want, but you're going to see it used as device quite often. So CUDA if torch.CUDA is available, else CPU. So all this is going to say, and we'll see where we use the device variable later on, is set the device to use CUDA if it's available, so it is, so true. If it's not available, if we don't have access to a GPU that PyTorch can use, just default to the CPU. So with that being said, there's one more thing. You can also count the number of GPUs. So this won't really apply to us for now because we're just going to stick with using one GPU, but as you upgrade your PyTorch experiments and machine learning experiments, you might have access to more than one GPU. So you can also count the devices here. we have access to one GPU, which is this here. So the reason why you might want to count the number of devices is because if you're running huge models on large data sets, you might want to run one model on a certain GPU, another model on another GPU, and so on and so on. But final thing before we finish this video is if we go PyTorch device agnostic code, CUDA semantics, there's a little section in here called best practices. This is basically what we just covered there, is setting the device argument. Now this is using the arg pass, but so yeah, there we go. args.device, torch.device CUDA, args.device, torch.device CPU. So this is one way to set it from the Python arguments when you're running scripts, but we're using the version of running it through a notebook. So check this out. I'll just link this here, device agnostic code. It's okay if you're not sure of what's going on here. We're going to cover it a little bit more later on throughout the course, but I'm gonna write here. For PyTorch, since it's capable of running compute on the GPU or CPU, it's best practice to set up device agnostic code. E.g., run on GPU if available, else default to CPU. So check out the best practices for using CUDA, which is namely setting up device agnostic code. And let's in the next video see what I mean about setting our PyTorch tensors and objects to the target device.